Hi everyone, today we are going to be learning about solving radical expressions, okay? So the first thing I want to let you guys know is that a radical is also another word for a square root symbol, okay? So when we say square root symbol is the same thing as a radical, okay? And the radical and square root symbol is this, okay? Another thing that is important to know for this lesson that I would write down if I were you is that the square root is the opposite of a term being squared, okay? So these two would be the opposite of each other, okay? What the opposite means is that one undoes the other, okay? You're going to learn that as we go along, but one undoes the other, okay? So for this first little part up on top here, I just want you guys to warm up, okay? I'm going to just start number 1 for you, and then I'm going to do number 2 for you. I want you to finish number 1, okay? So the first thing I want to do is I want to get x by itself, okay? So in order to get x by itself, I need to get rid of this denominator. How I'm going to get rid of this denominator is I'm going to multiply 7 to both sides, because then this cancels out. Okay, now I have 21 equals 2x minus 5, okay? This is just a two-step equation, so I want you to go ahead and do that on your own, okay? Go ahead and do that on your own. That's pretty simple, okay? Then come on over to number 2, okay? So what we want to do is we want to get x by itself, but notice x has an exponent attached to it, okay? The first thing I want to do, though, is I want to get this 4 to the other side. Okay, so what I'm going to do is I'm going to subtract 4 from both sides. My x squared comes down because I haven't touched it, and 13 minus 4 is equal to 9. Okay, now this is where this comes in. Okay, that's where that comes in. So we are trying to we need to get x by itself, which means this 2 needs to go away. Okay. Now, I told you that x squared is the opposite of the square root. So what I want you to do is you're going to take the square root of x squared. Now, remember, whatever you do to one side, you have to do to the other, okay? Now, this is very, very important, okay? When I have a square root and a squared term inside, they both cancel out, and the number or the variable drops out, okay? So my square root, my radical symbols, cancels out, and my 2 cancels out, and all that is left is x. Okay, now to find the square root of 9, we are looking for one number that multiplies by itself to equal 9. Okay, now we know that 3 times 3 is 9. Okay, so the square root of 9 would just be 3. Okay, so my answer is x equals 3. Okay, so that's going to be the basis of our lesson today. Okay, now I'm going to go on here and show you guys a few examples, and then these are just simple examples that are going to help you realize some things, and then we'll go on to the next page, which is a bunch of actual equations that we're going to solve. Okay, so now this number 1 is a little different than number 2, okay? The same concept, but just a tad different, and I will show you why, okay? So here, I'm going to write this a little bigger. We have square root of x equals 5. To get x by itself, we need to cancel out that radical symbol, okay? We need to cancel out that radical symbol. And how I do that is I take the opposite of the radical, okay? So what I'm going to do, the opposite is squaring. So I'm going to square both sides, okay? Now what I told you from the last problem is that the radical and the little 2 exponent cancels each other out. And all you're left with is x, okay? And then on this side, we have 5 squared. We all know that 5 times 5 is 25. So x equals 25. Now, when we are completing these problems, it's super, super, super important to check, okay? I know most of you want to skip this step, but you can't, okay? You have to check. So in order to check, what I'm going to do is I'm going to write my problem, back up the original problem, back up over here, okay? And then I'm going to plug in whatever I got for x. In this case, my x was 25. So I'm going to go ahead and plug 25 in where x was, okay? Now, this is how I check. We know that the square root of 25, so what one number multiplied by itself gets you 25? We know that that's 5, okay? Equals 5. So this checks because 5 does in fact equal 5. So we know that because this is right, that my x equals 25 is right. Okay? So now, we're going to go ahead and do this next one. Now, it looks very similar, but it's a -5 now. Okay? So we're going to do this problem out, and then I'm going to show you something after. Okay? So same step as here. I am going to square both sides so that my radical cancels out. Okay? Now, whatever is left in the radical drops down, and I have -5 squared. Now we know that -5 squared is -5 times -5. Okay? This gets me 25. So the same answer is up on top. Okay? So that gets me 25. But we need to check because this is going to show us something else. Okay? So I'm going to bring my original problem over. The square root of x equals -5. Okay? So same thing that I did up here, we're going to do down here. We need to plug in. Now, I know that my x equals 25. So every time I see an x, I'm going to plug 25 in. Okay? Now, here is what's important. I know that the square root of 25 is 5. But 5 does not equal -5. Okay? And why is this happening? Because it is not possible for the square root of a positive number to be negative. So here we had a positive 25 in my square root. It is not possible to ever equal a -5. Okay? It is not possible. So what I want you to realize, I'm going to note it over here. This is very important. Okay? When we have a problem that has a negative number after the equal sign, okay, and it's just the square root on one side and a number on the other, it will always be no solution. So we really did not have to complete all this work, okay? We saw that there is a negative with this number, okay? So because it's a negative, we know that it is no solution, okay? So that's important to realize. But what's also important to realize, it's only when it's a square root, okay? Or anytime it's an even power, okay? So 2, 4, 6, 8. Only when it's an even power. We're not going to go up to 4 through, we're only going to be sticking with 2 and 3, so you don't have to worry about that, okay? So when you have a radical and then a negative number, if it's negative, we automatically know it's no solution. You do not have to do any work to know that, okay? So, I'm going to go ahead and start number 3 and 4. Okay, now these are a little different because now I have the cubed root, okay? So rather than squaring each side, I'm going to cube each side, okay? So whatever number you see here is what you're going to do. When we look at these, we don't see a number because we know that it's just the square root when there's no number, okay? So I'm going to go ahead and start this one. So I have the cubed root of x equals 5. Now, instead of squaring both sides, I need to cube both sides. So this cubed root radical and this cubed root power cancels out. And whatever is under that radical plops out by itself, okay? And now what I have left is x equals 5 cubed, okay? Now what this means is 5 times 5 times 5, okay? And I know that 5 times 5 is 25, and then 25 times 5 is 125, okay? So here, my x equals 125, okay? But what we talked about is we need to check, okay? So I'm going to start with my original problem, and I'm going to have cubed root of x equals 5, okay? So the cubed root of x equals 5. Now here, what I'm going to do is I'm just going to plug in what I got for x into x, okay? So I have the cube root of 125 equals 5. And now to find the cubed root, we need to find one number that is multiplied 3 times to get 125, okay? And we know that we just multiplied 5 times 5 times 5. So we're multiplying 5 3 times to get 125. So that is what's going to plop out, okay? Is 5 equals 5. Now this checks. So we know that x equals 125 is correct, okay? We know that it's correct. Now we're going to go on to number 4. Now what's important to realize is we just can't write no solution because we see a negative, because there is a 3 here, okay? And I will show you why, okay? But same concept. We are going to take the cubed root of x equals negative 5. Now what I need to do in order to get this cubed root radical out is multiply each term, each side by 3. Don't multiply. You're going to cube each side, because then this radical and this power cancels out. And all that's left is x, okay? And now we have negative 5 cubed. Now this is a little different, okay? So important to pay attention here. This is negative 5 times negative 5 times negative 5, okay? We know that negative 5 times negative 5 is positive 25, but you can't forget that you have to multiply again by another negative 5. And 25 times negative 5 equals negative 125, okay? So my x here equals negative 125, okay? So same thing. Now we need to plug back in, okay? We need to check. So I have cubed root of x equals negative 5, okay? What I'm going to do is I'm going to plug in my negative 125 for x, okay? Oops, see? You got to be careful. I forgot to put a negative there, okay? And now, because I have a negative 125, I know when you're doing odd roots, okay, odd powers, you immediately have to know that your answer is going to be negative, okay? So this will be a negative 5 equals negative 5, okay? So this checks out. So important to realize that when we have a 3 here and a negative number, it is not no solution. That only occurs when it's a square root, not a cube root, okay? All right? Now we're going to move on to the next page, okay? Now we're going to start solving, okay? We're going to solve equations. What we were doing was just little one-step equations. Now it's going to get a little more difficult, okay? But there's no need to get afraid. It's very simple. We're going to work through it, okay? So, for example 1. When we're solving square root equations, it's very similar to just solving one-step and two-step equations, okay? We just have to get x by itself. And that's how we solve any equation, okay? Always, always, always are just trying to get x by itself, okay? So now on the front page, this is our first easy, simple equation, okay? What I need to do, though, in order to get x by itself and get that radical to disappear, okay, is I need to square both sides, okay? So I'm squaring both sides. Now, when I square a radical, it cancels out. So my radical cancels out, and my little 2 exponent cancels out, okay? So what's left is whatever is left under the radical, okay? So in this case, we just have x left, okay? So x drops out, and then I have 4 squared. We know that 4 squared is 4 times 4, so my answer is 16, okay? So x equals 16. Now important, gotta come check. Always, always have to come check, okay? So this was my original equation. Now I'm going to plug in my x. So now I have the square root of 16 equals 4. We know that this one number that multiplies twice to itself to get 16 is 4. Okay, the square root of 16 equals 4. So this checks out. They check out. Okay? Important to realize. Okay? Now we're going to go ahead and start solving some. Okay? We're going to solve actual equations. All right? So let's go ahead and do number 2. Okay? So what I'm going to do is I'm just going to go ahead and write it down again because that's how I prefer to do things. Okay? And then what we see that this radical goes over my whole problem. Okay? So we need to square both sides, right? Because this radical, we want it to cancel. Okay? So what drops out of the radical is x plus 4. Okay? And then on this side, I still have 2 squared. Okay? And then now we are just solving. Okay? So I'm going to do x plus 4 equals 2 squared, which equals 4. And now it's a one-step equation. I just need to get x by itself. And I would subtract 4 to each side to get x by itself. Okay? Now, in this case, we have x equals 0. Don't forget, we need to go ahead and check. Okay? So I am going to go ahead and check my answer by plugging x back into my original problem. Okay? In this case, it was x equals 0. Now, when you are checking, only when you are checking, you want to make sure that you are doing what's under the radical first. Okay, so we have the square root of 0 plus 4, which we know is just 4. Okay, 0 plus 4 is just 4. Now, we know that the square root of 4 is 2 times 2, right? So what drops down is 2 equals 2. We know that x equals 0 is correct because 2 does indeed equal 2. Okay? We're going to go ahead and now do example 3. Now, do not get nervous because you see a fraction. Okay? Do not get nervous. All right? So what I'm going to do is write my problem over again for you guys. Okay? And I need to square each side. Okay? So I'm going to square this side, and I'm going to square this side in order to cancel out my radical and my exponent. Okay? Whatever is left drops out. Okay? So 2 over 3x plus 5 equals 10 times 10, because this is 10 squared. And 10 times 10 is 100. Okay? Now I am just solving to get my x by itself. Okay? So I just need to solve. All right? So what I'm going to do is I'm going to subtract 5 first from both sides. And now I'm left with 2 over 3x equals 95. Okay? Now, in order to get rid of a fraction, what we always need to do is multiply by the denominator first. Okay? So, we have 3. These 3's cancel out. Okay? Because one's on the top, one's on the bottom. They cancel each other out. Then we have 95 divided by 3. 95 times 3. Okay? This gets me 285. Okay, so I'm going to go ahead and write over here because I don't have enough room. And what I'm left with is 2x equals 285. Okay? I am then going to go ahead and divide each side by 2. Now, this does not divide evenly. So I am just going to keep it in my fraction. Okay? So I'm just going to keep it in a fraction. All right? So now I have this. Now, I have to go check again, right? I have to check my answer. So I'm going to bring this over here, and I have the square root of 2 over 3x plus 5 equals 10. Okay? Now I'm going to plug in. So now I have the square root of 2 over 3. I am plugging in, oops, see, don't forget that. I am plugging in 285 all over 2 in for x, okay? Now, like I said in the last problem, you always do what's in the radical first, okay? So I'm going to multiply my fractions. We remember how to multiply fractions, just multiply across. So 2 times 285 is 570, okay? And then 3 times 2 is 6. Don't forget the rest of the equation. Okay. Oh, what am I doing? Equals 10, okay? Now, this divides evenly, okay? So 570 divided by 6 is 95, okay? So now we have the square root of 95 plus 5 equals 10. Now we can still do what's under the radical, okay? We could still do what's under the radical. And we know that 95 plus 5 is 100, okay? Now this checks out because the square root of 100 is 10, and 10 equals 10, okay? So this x is correct, all right? So that's how you would do one with a fraction. Okay, we're going to come over to number 4. Now, with number 4, there is one step that I want you guys to take before we square each side, okay? And that is adding 3 to both sides. This will make your life a lot easier, okay? It will be a lot more simple. So now these cancel out, and we're left with the square root of negative 3x is equal to 7, okay? Now we want to square both sides so we can get rid of the radical, okay? So my radical cancels, my 2 exponent cancels, and whatever is left in the radical drops down. So negative 3x equals 7 squared. We know that 7 squared is 49. Okay, we are not done though because we need to divide each side by a negative 3. These will cancel out, and now I have x all by itself. These are not divisible, okay? So I want you to keep it in the fraction, okay? Keep it in the fraction. So now that I have my x, I'm going to come back up and check my answer. So now I have negative 3x minus 3 equals 4. Notice that this 3 is not in the radical. That's important, okay? Not in the radical. Then I'm going to go ahead and plug my x in. And my x is this fraction, 49, divided by negative 3. Okay? And then minus 3 equals 4. Now, always, always, always do what's in the radical first. So when I have negative 3 times 49 over negative 3, what I realize is that these 3's cancel out because they're the same number on the top and the bottom. It will be easier because at the end it would just simplify, but here we're going to skip a step, okay? So we're just going to cancel both of those 3's out, and whatever is left drops down. So I have the square root of 49 minus 3 equals 4. Now we have to add the 3 to both sides, okay? Now we know that the square root of 49 is 7 times 7, so my 7 drops out. This checks. So this is the right answer because 7 does indeed equal 7. All right? Now, this one's a little different because now this number is inside the radical. Okay, so that makes a difference. So I'm going to go ahead and write everything down. Okay, with that negative 5 inside the radical. Okay, so what we're going to do here is first step, we got to get rid of that radical. So I'm going to square each side. Okay, so when I square each side, my radical cancels and my exponent cancels. So I'm left with whatever was under the radical, which in this case is 3x minus 5 equals negative 7 squared. Okay, And negative 7 squared is negative 7 times negative 7, which gives me a positive 49 because a negative and a negative equals a positive 49, okay? So now I'm left with 3x minus 5 equals positive 49, okay? Now this is just a two-step equation. So I'm going to add 5 to each side to get me 3x equals 54, okay? Those 5s cancel out. And then we need to divide each side by 3, okay? So I am dividing 3 and 3. These 3's cancel out. And this is divisible, okay? So 54 divided by 3 is 18. So this is my new x, okay? So what I'm going to do is I'm going to take my original equation and I'm going to go ahead and check, okay? But now I'm plugging in 18 for x, okay? So I am just changing different colors so you guys can see. And then you need to do whatever is under the radical first, okay? We know that 3 times 18 is 54. So under my radical, I'm going to have 54 minus 5 equals negative 7, okay? Now, under my square root, you're still doing this first. 54 minus negative 5 is 49, which equals negative 7. Now here is like I talked to you guys on the first page. When you have a negative number with a square root, right? A square root radical. This has to be no solution because square root of 49 is 7, and this does not equal one another. 7 does not equal negative 7. Okay, so we know because this is a negative 7 that it means no solution. Okay? So that's how we would do those 4 examples. Okay? These are all the square root. On the next page, we're going to do some radicals. Okay? Cube root radicals. So, just like we were doing with those problems, instead of squaring each side now, we need to use the number that we see here, which is 3, okay? So what I'm going to do is I'm going to cube each side now. No longer squaring, I'm cubing each side, okay? When I cube a cubed root, they cancel each other out. So this cancels, and my exponent 3 cancels, and I am left with whatever was under the radical, which in this case was just x, okay? Now, I need to cube my 6. So this means 6 times 6 times 6, okay? And I know that 6 times 6 times 6 is 216, okay? Now that I have my x, I need to go ahead and check, okay? So I write my original equation down, and then I'm going to plug in my x, which was 216, equals 6, okay? And like I just showed you guys here, I know that 6 times 6 times 6 is 216. So the cube root of 216 is 6. And 6 times 6 does equal 6, so we know that x equals 216 was the correct answer, okay? Now I'm going to go ahead and do the same thing for example 7, okay? So here I am, just writing the problem down again. Now, in order to get rid of this radical, I need to cube both sides, okay? So, in order to cube both sides, this drops out. My exponent 3 goes away, and I am left with whatever is left inside, okay? So I know that negative x plus 7 equals, this is 5 times 5 times 5, which I know is 125, okay? And now we just have a two-step equation here. Two-step equation, okay? We need to get positive x by itself. So what I'm going to do is I'm going to subtract 7 from both sides first, and I'm left with negative x equals 118, okay? But I can't have a negative x So I need to divide each side by a -1 in order to get these negatives to disappear. So now I'm left with x equals -118. Okay, so this is my answer, but I need to check to make sure I was correct. Okay, so I'm going to write it back down, my original equation back down, and we're going to check. Okay, so now I'm going to plug in. Remember, there is a negative already in this problem, and then a negative with your answer. Okay, that's important to realize. Now, we are going to do whatever is under the radical first. Okay, so the first thing I need to do is multiply this negative and this negative. So now I have the square root of 118 plus 7 equals 5. Notice this is a positive 118 because a negative and a negative make a positive. Okay, now I'm going to add, and this gets me 125 because 118 plus 7 is 125. Okay, my last part of checking is realizing that I know that the cubed root of 125 is 5. These in do check out, which means x equals -118 is the correct answer. Okay, all right, last one, and then we're done. Okay, so last one. Here, just like we did on the prior page, I realized that this +9 is outside of the radical, okay? So what I'm going to do first is I'm going to subtract 9 from each side, okay? So now I have the cubed root of 3 over 4x minus 7 equals 3, okay? Now what I can do is cube each side, okay? So I needed to take this step first, but now I could cube each side, okay? When I cube each side, the radical cancels and the exponent 3 cancels. So anything that's inside the radical drops out, okay? So now I have 3 over 4x minus 7 equals 3 cubed, which just means 3 times 3 times 3. And I know that 3 times 3 times 3 is equal to 27, okay? Now what I'm going to do is it's a two-step equation now, okay? I need to get x by itself by adding 7 to both sides, okay? So when I add 7 to both sides, this cancels out, and I am left with 3 over 4x equals 34, okay? Now, in order to get rid of this fraction, I need to multiply each side by the denominator, okay? So these 4's are going to cancel out, and 34 times 4 is 136. And on this side, I'm left with 3x equals 136. Now, I'm not done because I need to divide each side by 3. Okay? Now, this is not divisible. Okay? So I'm going to leave it in fraction form. So here is my answer for x. Okay? Now what I'm going to do is just like any other problem, I need to check to make sure that this is the correct answer. Okay, so I'm going to go ahead and write my problem down again. And then I'm going to plug in for x. Okay, so here I am plugging in for x. Minus 7 plus 9 equals 12. Now, like I've said with every other problem, you need to do what's under the radical first. Okay, and we know how to multiply. Okay, so we are going to do 3 times 136. And that's how we multiply to get the top. Okay, so here, I know that the answer is 408. Use a calculator for this. Okay, and then I know that 4 times 3 is 12. Okay, so here, okay, I still need to write my 7. I'm going to finish writing my equation, okay? It's important to realize that this divides perfectly, okay? And it is 34. Okay, this is 408 divided by 12 is 34, but I still have to subtract 7 and finish writing my problem. Okay? Now, like I said before, always do what's inside the radical first. Okay? And 34 minus 7 is 27. Okay? I'm going to keep finishing my problem. Now, you need to find a number that the same number that multiplies 3 times to get 27. And I know that 3 times 3 times 3 is 27. So 3 is going to fall out of my radical. Okay, so then I'll have 3 plus 9 equals 12. And I know that 3 plus 9 equals 12, which equals 12. So it turns out that x equals 136 over 3 is correct. Okay? If you have any questions, please let me know. This was our lesson for the day, okay? You're going to have some practice problems, all right? If you have any questions, let me know.